Hello and good afternoon, everyone. Welcome to another live session at the Reactors. My name is Rav and I'm the program manager here at Reactor London. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful, please be kind, please be considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. We're back with another Game of Learners episode. So today we'll be talking all about visual machine learning using Azure ML, and I'll be putting the resources in the chat. And with that, I'm now going to add Josh to the stream and he will take over. Hey, Josh.
Hi, Rob. Thank you. So, as Rob has mentioned, my name is Josh. I'm a cloud developer advocate here at Microsoft in the data engineering and analytics team. And today's session is the second episode in the Game of Learners Clinics. And by the end of this session, we need to have covered the basics of visual machine learning using Azure ML. And what we're going to cover today, we'll just have an introduction, just a quick introduction to what machine learning is. Maybe this has already been covered in a previous episode. We're just going to highlight what machine learning is, then look at what Azure machine learning is. And using a deep dive on Azure, we're going to explore the Azure Machine Learning Designer and then understand the different steps for regression on Azure ML. So this is going to be a live and interactive session. So as Rob mentioned, just ask questions in the chat. I'll respond to them as we proceed, and I'll also address some of them at the end of this session. So just keep asking your question and or your comments on the chat section. So let's get started. What is machine learning? Recently, or in the recent past, there has been a lot of engagement and a lot of talk around artificial intelligence, and we can be able to see the different applications of artificial intelligence. And machine learning is the basic foundation of most artificial intelligence solutions. So when you think of creating an AI solution, this will always begin with machine learning, maybe training machine learning models to predict certain labels based on historic data. And you can think of machine learning as a technique that uses mathematics and statistics to create a model that can predict unknown values. So, for example, uh, think of a company called AdventureWorks, which is in the business of renting cycles in a city, and the business wants to optimize the rentals for each particular day. So the business could use historic data to train a model that can predict the rental demand in a day, and this ensures that they have sufficient staff and sufficient cycles for that particular day. Now, to do this, AdventureWorks will create a machine learning model that takes the information about a specific day of the week, the anticipated weather conditions, and so on as an input, and then uses this information to predict the number of rentals as an output. Now, mathematically, when you think about this, you can think of this as a function. Let's call this function f that takes in some variable x. Now, this variable x, as I mentioned, could be things like maybe the weather conditions, the day of the week, and then this is used to predict a label y, which in this case is the expected number of rentals. So you can think of this as a function f of x, which outputs a label y. So the specific operation that this function f performs on x to calculate y will depend on a number of factors. So these will include maybe the kind of model you're trying to train, the specific algorithm you're going to train your model, and most importantly, the data that you're going to use to train your machine learning model. Because the data you're using might require some pre-processing before it's ready for training. Now that we've mentioned we've just identified or rather explained what machine learning is. There are several approaches of machine learning. There are three broad approaches to machine learning. The first one is unsupervised learning. So in unsupervised learning approach for machine learning, this starts with a data set without known label values. So think of this: you have a data set, but you don't know its labels. So an example of this might be a clustering problem. An example of a machine learning task which uses the unsupervised learning approach is clustering, and this can help answer questions like, how is this data organized? Is there any relationship between these data? So you just give the model data, and then from there it's able to identify relationships or patterns within the data. And the other approach is supervised learning. And now in supervised learning, this is just like the same example I gave in AdventureWorks. So in this approach, you start with a data set with known label values. So, and then you use these known label values to predict unknown label values. So you have a labeled data set. Like in the case of AdventureWorks, we have a data set that has, the different days of the week, the weather conditions in those particular days, and then we have the rentals, like, how the demand of the rentals for that particular day. And now using that, we can be able to give the model similar input without the label, similar input without the label, and it can be able to make the prediction. So types of supervised learning machine learning tasks, these include things like regression. So in the case of regression, so we use this to predict a continuous value, like maybe price, sales total, and the other one is classification. So in this, we are able to determine a class label. So like, for example, you can try to determine a classification, like whether a patient has diabetes or they do not have diabetes. And even in some cases, you can have multi-class labels where you're classifying maybe things like whether a particular text is positive, negative, or neutral. So these are some broad categories of or broad approaches to machine learning. And we have a final one, which is called reinforcement learning, which is completely different from supervised and unsupervised, because in reinforcement learning, we don't have the features, not the labels, but we allow the intelligent agent to explore the environment, and then based on that, it's able to learn about the environment and take particular actions. For purposes of today's session, we are going to constrain ourselves to supervised learning and particularly regression, so that we can be able to understand how you can build your regression solution on Azure ML. Now, what is Azure Machine Learning? What is Azure Machine Learning broadly? Now, we've already seen different machine learning approaches. We've already identified what machine learning is. And one of the things we've kept mentioning across those two slides before, is that when we need to train and we need to deploy a machine learning model for the end user to consume it. So when you're training and also deploying an effective machine learning model, this will involve a lot of work, and a lot of times it's going to be time consuming and also resource intensive. Now, Azure Machine Learning is a cloud-based solution that will help simplify some of these tasks, especially tasks like data preparation, training the model, deploying the predictive service. So it helps simplify some of these tasks, and importantly, it's going to help data scientists to increase their efficiency by automating many of these time-consuming tasks associated with training models. As you're going to see today, once we open the designer, you're going to see how effective or how fast it can be to build, train, and even deploy your machine learning model. And the last important thing that Azure Machine Learning provides you with, it's also going to provide you with compute resources, because as we said, to train and deploy the model, in as much as it's time consuming, it's also resource intensive. And so Azure Machine Learning also provides you with cloud-based compute resources that can scale effectively, and they are able to handle large amounts of data while incurring costs only that are actually used. So like, you only pay, or rather you incur the cost for only the resources that you've actually used. So I'm going to pause right there and switch. I'm going to pause right there and switch to the Azure portal, and we can be able to create the Azure machine learning resource and progress from there. So let me switch to the portal. Oh. Okay. Yeah, okay, finally. Right, so I'm just going to launch the Azure portal. And one of the prerequisites I forgot to mention is, you just need to be able to navigate through the Azure portal. Now, here I'm on the Azure portal, so I'm just going to I'm just going to come right here. Sorry about that. So I'm going to click on home, and then we're going to create a new resource. And right here, I'm just going to search for Azure Machine Learning. So Azure Machine Learning there. And I'm going to select this one and go ahead and create. So if you don't already have a resource group, you can create a new resource group. So you can create a resource group. I'm going to call this AI Clinics Live. And then you need to provide a workspace. You need to provide a workspace name for Azure Machine Learning. So the workspace, when you're creating your Azure Machine Learning resource, you need to first create a workspace resource in the subscription. So we're going to create the workspace and give it a name. I'm just going to call this AI Clinics Live. I'll select the region. I'm just going to leave that at West Europe. And then for the storage account, you can click on create new and provide a name for that. But or alternatively, you can just stick with the defaults. But the container registry, you can create a new one as well. Maybe give it a name, Clinics Live. And then click save. And then once you're done, just click on review and create. This takes around 2 minutes to complete. In the interest of time, I had already provisioned the resource. So once you click review and create, it should go ahead and provision all the resources. So you can be able to see we have the machine learning workspace. We also have the container registry. So like once you are ready to deploy your models, you can deploy them through the Azure Container Registry. We also have the Key Vault and also the storage account. That all of these are associated with your workspace. Now, once you've finished creating and provisioning is successful, just open on the Azure Machine Learning workspace, and inside here, just click on Launch Studio. And this should launch the Azure Machine Learning Studio, which is a web portal for machine learning solutions on Azure. So this is where you'll be designing, building, training, and even deploying your machine learning models on Azure. So Azure Machine Learning Studio will include a wide range of features and capabilities that will help you prepare data. And we're going to see this in a short while. It helps you prepare data, train your models, and also publish your predictive services, and also monitor their usages. So it comes in handy, and this is like where you live and breathe when you're building your Azure Machine Learning solutions. Now, one thing I mentioned along the way when talking about Azure Machine Learning is that it helps you with provision compute instances or compute clusters that you can be able to use for your machine learning tasks. And that's the first thing we're going to do. So you need to come underwrite under compute, and we have different compute resources which you can use to train your machine learning models. The first one are compute instances. So compute instances are development workstations which you can use to work with data and models. We also have compute clusters. So compute clusters, these are scalable clusters of virtual machines for on-demand processing of experiment code. And we also have attached compute. So like maybe if you've already created uh, some compute, you can be able to attach it right here. For purposes of this demo, we're going to use a compute cluster. So just click on create a new compute cluster. Select the same region as where you deployed your machine learning workspace. And then from here, you can be able to select the different VM sizes. To learn more about these virtual machine sizes, you can always click on this information tab here and click on learn more, and that should open a new tab. And from these, you can be able to learn about the different VM sizes, and you can be able to see which one is appropriate for your particular solution. So I just go with the recommended one right here and click on next, and then just give these a name. So I'm just going to call these AI clinics 5. The minimum number of nodes, I'll leave that at you can just have that at 1, or yeah, the minimum I can just have it at 0. The maximum I can just have that at 2, and then just leave everything else as is. And so when you do that, it's going to go ahead and provision your compute. This takes some time. This takes some. Oh, this didn't take long. But yeah, I had also provisioned another one ahead of time. But yeah, so we've already created our compute, and now once we've created our compute, we're going to head over to the designer. Now, once we're here on the designer, the Azure Machine Learning Designer, think of this. I mentioned like when you want to train your AI models or your machine learning models on Azure, you use the Azure Machine Learning Studio. Now, on Azure Machine Learning Studio, there are several ways you can author you can author your machine learning models. And one of the ways is using the designer. So you can be able to see we have different ways to author. So one is notebooks. So with the notebooks, if you've used things like Jupyter notebooks in the past, that's exactly what it is. So you're going to write your machine learning, your code, your ML code, and in the notebooks. We also have automated ML. So with automated ML, this one finds the best model for your data, and you don't like write any code. So like you can bring in your data, and then the auto ML will find the best model to train your data. And then the last one is the designer, which is what we're going to explore today, which leverages the pipelines, the training pipeline. So you create your training pipeline where you bring in your data, you clean your data, you train, and then you test, and you finally deploy your model. So we're going to create a new pipeline. And the first thing I'm going to do is bring in the data for our regression model. So okay, so I'm just going to search the data set right here. Let me see. So we're going to search for the automobile data set. This one here. I'm going to drag it inside here. And we have the data set. Okay, just to take you a step back before we start designing the pipeline. Once you create a new pipeline, I forgot to mention we need to configure our settings. So I'm going to click right here on these settings, and I'm going to select the compute. So I'm going to select the compute type is the compute cluster, and I'm going to select the compute cluster we just created. So we created the AI Clinics Live. I'm going to select that, and then you can change the draft name here and a description. I'm just going to leave those as they are and click on save. So what that means is every time we are running or testing or validating this pipeline right here, that's going to happen against the compute cluster that we've attached. So I'm just going to go ahead and close that. Now I've brought in the automobile data, and if you don't want to use the inbuilt data set, maybe you have your own data set, you can always click here and you can be able to upload your data set. So I've brought in the automobile data set, and what I'm going to do is I'm going to right click on the I'm going to right click on it and click on preview data so that we can be able to see the kind of data that we are working with. As you can see, we have different columns inside here. We have normalized losses, we have make, fuel type, and quite a number of them. And the last one right here is the price. So if you think of what we had mentioned about regression and also supervised learning, we have a set of features. So these are our features all here, and then we have our label price, which is what we are predicting. So you can be able to see all these different features, and this is what we'll be predicting. Now, another thing to notice, if for example I click on this column called normalized losses, and you can be able to see the different statistics for it. But what I want to highlight is you can see some of these values on different rows are empty, and so we need to somehow clean this data. We actually need to clean this data before we use it for training our machine learning model. So that's the first thing we need to do. The first thing we need to do is actually clean the data. So once we clean the data, then we'll ensure we have the data it's ready for machine learning. So we're going to apply some data transformations for that to do that. So to do that, I'm just going to come inside here and search for select columns in dataset. So select columns in dataset, and I'm just going to bring it right here, and I'm just going to join these two nodes. And then once we do that, we select the columns we want to work with. So we just double click that, and then we're going to select the different columns that we're going to be working with. So I'm just going to click on edit column, and then we select all the column names that we want to include. So here I'm going to select normalized losses. So I'm going to select normalized losses. And then click on click save. Also going to select sorry, I just need to do here by name, and then I'm just going to select all of them, all of the columns. I'm just going to click add all apart from normalized losses like that. Then I'm going to click save, and then we're just going to go ahead and close that. So we've already selected the different columns that we're going to use in the data set. The next thing we're going to do is to clean missing data. So I'm just going to search for clean missing data. I'm just going to bring that right here, and I'm going to link these two nodes, and then again, just going to double click. So we need to select the columns that need to be cleaned. We need to select the columns that need to be cleaned. So just going to click on edit column again. Column names. Sorry about that. Sorry. So let's select the columns that we're going to use for cleaning. So I'm just going to select price. I'm also going to select. Let's go back and see all the different columns we have. There was also model. Let's see. Let's go back and ensure we can get all the columns that we need. I'm just going to copy all these different columns that we need right here. I'm just going to copy that and edit column again, and then we can just bring them all in and so good. And then I'm just going to close that. After cleaning missing data, we're going to normalize. So I'm just going to come here and search for normalize data, and bring that in as well. And then again, we're going to select the transformation that we're going to be using. So I'm just going to double click again, and then the columns transform again. Going to use the column names. I'm going to bring in our columns again, and then click on save. And sorry, we need to, because we're predicting price, I'm going to remove that. I forgot to do that in the previous one. And then for the transformation method, we're going to use min-max, and then close. And then here I also need to make the changes for cleaning missing data. Also remove price. So, and then I'm going to save. And then from that, now we're going to link the cleaned data set with the normalization. So we've already connected everything. So I'm going to close there, and then I'm going to click on save. I'm going to save this, and then we're going to validate. So that looks okay. So what we're going to do so far, we've just performed some data transformation. So we've brought in our data, we've selected the columns we want to use for training, we've cleaned missing data. So here we are removing any missing data we might be having. And then we're going to normalize our data. So let's first validate everything we have so far that it works. So I'm just going to click on submit. And I'm just going to create a new experiment because we don't have any experiment. I'm just going to give these a name first. And then I'm going to submit. So that's going to take a few minutes to run. And as we As we're waiting for that to run, you can be able to see it's running. Job detail, you can be able to see it's still running. Yeah, so it's running. As that runs, let's go back and just recap or review what we've just covered. So, one, we've been able to explore what Azure Machine Learning Designer is, and we've seen there are different ways for you to author your regression machine learning models. You can either use notebooks, automated ML, or Designer. For this case, we're going with Designer. And when you're using the machine learning Designer, each project in the Designer is known as a pipeline, and on the and you can be able to use the different building blocks or the different components in a designer needed for your machine learning model. You just drag them and you drop them onto the canvas, and then you can be able to connect all of them and run your machine learning model. Now, pipelines, as I've mentioned, as I've mentioned in here, each design project is known as a pipeline, and so pipelines will allow you to organize, manage, and reuse complex machine learning workflows across projects and users. So each pipeline will start by importing a data set which you want to train the model. And every time you run a pipeline, the configuration of the pipeline and the results, they are stored in your workspace as a pipeline job. And you've seen that so far. We've already created a pipeline and we started by bringing in the data. And after that, when we've submitted our experiment, the configuration has been stored in the workspace as a pipeline job, and you've seen the job running. And this is what I mean right here. You can be able to see the pipeline configuration has been submitted. The other thing we've also seen are components. So in Azure Machine Learning, a component encapsulates a particular step in the machine learning pipeline. So you can think of a component as a programming function and as a building block for Azure Machine Learning pipeline. So each particular task you want to achieve uh, is achieved by use of a component. And so you can be able to access the different components from data assets, the different data assets and components uh, right here from the left tab of the assets, from the left panel of the asset tab. The other thing we've also seen are data sets. We've seen you can bring in your data. You can bring in data. You can upload that from your local files and upload them into the machine learning workspace. Alternatively, you can also use the open data sets that are also built into the Azure Machine Learning workspace. And the last thing is that we've seen the other machine learning jobs. So when we've submitted the job, so that it executes a particular target against the specified compute. It executes a particular task against the specified compute target. So in the Azure Machine Learning, when we've created a job, the Azure ML will maintain and run a record of the job, as I've already shown, and all of your job records, you can be able to see them, you can be able to view them directly within ML Studio. So we're going to go back and see whether the job has finished running. It's still running, and I'm going to pause and ask whether we have questions. Rob, do you have any questions from chat? Rob, are you able to confirm whether we have any questions?
Yes, so we have one question. Sorry, but can you hear me?
Yes.
Okay. What is, well, I'm not sure what the context is here, but what is resource group?
Okay. So when I was creating this resource, the Azure Machine Learning resource on Azure, I started by saying we create a resource group. And let me just launch the Azure portal quickly just to explain what the resource group is. So you can think of a resource group as a container or as the way we organize our different resources on Azure. So for example, we have this resource group called AI Clinics Demo, which is what we're using for this particular demo. So you can see inside the resource group, we have these different resources. So we have the Azure Machine Learning Workspace, we have the container registry, we have a key vault, we have a storage account. So all our resources are organized inside a resource group. Different people and different organizations use different approaches in terms of how they organize their resource groups. There are people who will have all resources, all similar resources in the same resource group. So like they have like maybe all their key vaults in the same resource group, all container registries in the same resource group. Other organizations and other individuals will opt to have it project based, like the way we've done in this approach. So we have all the resources for this particular project in the same resource group. So think of a resource group as the way we organize resources in on Azure.
Okay, great. And the next question is how much credit it requires to try out Azure Machine Learning?
I'm not certain about the credits, but you can check out the Azure calculator. If you just do a quick search for the Azure calculator, you can and put in the Azure ML, you can be able to see how much it actually costs. I don't know the figure of it, but I'm sure you can be able to get that directly from Azure calculator. I'm going just to do a quick search of Azure calculator. Yeah, this one right here. And I'm going to put these on chart. You can just use the Azure calculator to see how much it's actually going to cost to for your Azure ML workspace. Right, send the link on chart. Okay, let me pause there and let's see. Seems like the job failed. Let's see why. Ah, normalization. So you can be able to see this passed, this one failed. Okay, I know why. So let's go back and edit it out. So I'm just going to go back to the designer. Going to- I'm going to come here and try edit this out. So let's see. Okay. So I'm going to edit the columns that we have here. That's where the problem is. So we need the symboling. We need. Let's remove all that. Let's remove that. We need the wheelbase. The wheelbase, the length, the width, the height, the carb weight, the engine size. So the engine size, we don't need engine type, we don't need the cylinders, fuel system, no, we need the bore, the stroke, the compression ratio. Yes, it's like that. And that should be able to fix the issue. So because it's taking time, I'm just going to finish the entire process and then we're going to go ahead and run it at the end. Now, once we've finished, you can think of this as your data preparation part of the pipeline. We can go ahead and create the training piece of the pipeline. Now, now that we've already created the transformation to prepare the data, now we can now use the data because we believe our data is already clean and we've also done some normalization. So we're going to split our data. Some portion of it use it for training, and some portion of it use for testing. So I'm just going to come here and search for split. So we're going to split our data, and we're going to connect these. We're going to connect these one here. So the transformed data, and then double click this so that we can be able to select the splitting. So we're going to split these in rows. So we're splitting rows, and then we're going to use 70% for training and 30% for testing. Going to randomize, and then select maybe to 3, and that to false, and then we're good to go. And then from there, after splitting, we're going to add a train component. So search for train. I'm going to bring in the train right here. And then in the train model, so here you can be able to see under the split, we have 2 nodes. So you can see the first one here. I'm going to connect, I'm going to connect this one to the data set. I'm just going to bring this one right here. And then double click the train so that we can be able to select the training algorithm and also select our label. Remember, we mentioned you can think of this as a function of f of x, which gives y, and y is our label, and all the other columns we've selected to use for training are our x. So I'm going to select here, and I'm going to select these as price. Save. And then the other thing we're going to do is, so we've already selected that. Then the other thing we're going to do is bring in the training algorithm. So we're going to look for, because there's a linear regression problem, we're going to look for a linear regression component, bring it here, and we're going to link that one right there. So we're going to connect it to the untrained model. And then the last thing we're going to do is bring in a score component. So the score model, we bring that one right here. And so this takes the output from the trained model and the other output, because we're going to score it against the remaining part, the remaining set of this split data. So everything looks okay. We're going to click on validate, and we're going to submit. So again, just going to use the first experiment I want to create, and then maybe I can maybe change the name and maybe say add pipeline, and then submit. It might take a few minutes to complete. So it's submitted. So it's running. So again, it might take a few minutes for it to complete. So all right, as we are waiting for FAT to run, now I'm going to bring in again some. So I'm just going to bring in these slides so that. So let me bring in my slides. Okay. So just to cover the different steps that we've done for regression, and the first one was we've prepared the data. So we've identified the features and the labels in the data set. We've done some training and some transformation of the data as needed. Then we've split the data into two groups, a training set and a validation set. So we're going to train the machine learning model using the training set, and then we're going to test the machine learning model, or rather to test its performance using the validation data set. Now, the next step, which we haven't done yet, is the evaluation of the performance. So we're going to do that once the job finishes running. And the final step is to deploy a predictive service that you can be able to use to predict the price of an automobile. So just to highlight, to prepare the data, we used the clean missing data component and also the transform data component. To train the model, because this is a regression model, we took in the 70% from the train set, the 70% train set data, and we used the regression model to train the model. And the last thing, we also added a score model component, which is used to generate the predicted class level value. And once you connect all these components together and run the experiment, it's going to evaluate. It's going to not evaluate. It's going to generate a class label against, and just see like whether the training, or rather evaluate the training of your machine learning model. So this may take a few minutes. And I'm going to pause again and see whether we have any question.
So I think the next question we had was, what's the need of data transformation, and mathematically, how do we achieve this?
Okay. I'm going to come back and bring in and try to preview this data. If we preview the original data that we have, and I'm going to use one of the columns that we're using in training, for example, the length. If you look at this data, we have some values that are very low and others are very high. So once we do our data transformation, we try to reduce these variations. And I wish this can finish and I show you the output from here after normalizing. We tend to have some form of in as much as not consistency, we tend to have some form of balance. We don't have values that are way on the extreme and values that are also way on the other, on either side of the extremes. So that's what we do with the normalization, so that we can have some sort of normalized data for our training model. And you can be able to see, because I'm worried time might not allow us, but once you run this experiment, I would like you to compare the data, the original raw data, and you can just right click here and see the output from the normalized data and see how that varies as well.
Okay, and the next question is also on resource group. Can I use an already set Azure VM with all necessary resources to create Azure ML pipeline, or all must start from Azure ML Studio?
Right. So as I mentioned, when you want to train your model and maybe you already have your compute created, you don't need to create a new compute instance. You just need to come and under attached compute, you just come here and select. So for your case, you're saying you already have a virtual machine. Just select on virtual machine and come and provide the different credentials right here. And once you're done, you should be able to come back to the designer and inside inside here from the settings part, you can be able to select attached compute, and then you select the compute that you've already attached to your Azure Machine Learning Workspace.
Okay, and then can you open source code of the flow and make changes there?
Pardon?
Can you open source code of the flow and make changes there?
Okay, so for the designer, you can't use you can't use the source control like Git. But when you're using the notebooks, that's a possibility. You can be able to do that. But if you want to collaborate within, the Azure Machine Learning Workspace, you can be able to add collaborators inside your machine learning workspace, and you can be able to collaborate with other individuals as well. But for the designer, no. But for your notebooks, you can be able to come inside here, and you have access to your terminal. So like if so, I'm already I need to create a new compute for the terminal. But you already have access to the terminal. You already have access to the terminal right from inside here, and you can be able to use Git and maybe push or collaborate or with other individuals as well. But for the designer, you just need to add them to your workspace. You just need to add other collaborators to your workspace, and that's it.
Okay, thanks, Josh. And if you could share your LinkedIn details towards the end of the session, as I suppose some people would like to connect with you on LinkedIn.
Okay, thank you. So I see we have a few minutes to go, and the model might not complete training before then. So I'm just going to highlight the last remaining pieces of this, and you can be able to complete that on your own. So we've already got to this point where we've trained and scored the model. Now, after that, the next step is to evaluate performance. So after training your machine learning model, it's very important to evaluate its performance. And so there are very many performance metrics that you can be able to use to evaluate how well your model makes predictions. And you can review these metrics by clicking on the evaluate model component. So you'll just add uh, the evaluate model component, and you just link these with your score model, and then you'll be able to perform the evaluation. You can be able to see the different matrices that you can use. You can use the mean absolute error, the root mean squared error, and all of this information is on the learn module that we've already shared with you. Now, after evaluation and you're confident and comfortable with the results you're getting from your trained model, the last step is to deploy your model as a predictive service. So you have the ability to deploy the service that can be used in real time in order to automate your model into a service that makes continuous predictions. And the good thing is, after deployment, you can always be able to retrain your model and make updates to it. Now, since the time is almost done, we can just like do a quick knowledge check. We can do a quick knowledge check in terms of everything that we've been able to cover today. So, um, in Azure Machine Learning Studio, what can you use to offer regression machine learning pipelines using a drag and drop interface? Is it A, notebooks, B, automated ML, C, designer? I'm trying to see in chat whether we have any responses. C, yes, correct. So we use designer for drag and drop. With notebooks, you write your code. Automated ML will select the best, the right algorithm for your training. The other one is you're training a pipeline for a regression model. You use a data set that has multiple numeric columns in which the values are on different scales. You want to transform the numeric columns so that the values are on a similar scale. You also want the transformation to scale relative to the minimum and the maximum values in each column. Which module should you add to the pipeline? Select columns, clean missing data, normalize data. I see for the first question, most people answered C, which was correct. Let's see what we have for the second one. Yeah, I see people coming in. C, yeah, C. All right, so most individuals say C. And yes, the correct answer is C. When you transform numeric data to be on a similar scale, you use the normalized data model, as I had just explained shortly. And then the last part of our knowledge check. Why do you split data into training and validation sets? Now, data is split into two sets in order to create two models. Splitting data into two sets enables you to compare the labels that the model predicts with actual known labels. Only split data when using Azure Machine Learning Designer, not in other machine learning scenarios. So which one do you think this might be a little bit, a little bit confusing, but let's see what you have as your answers. Waiting for some few answers, just a few. We can have a few coming in. See B, Kara says B, Marek says B, 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 yes, and that's the correct answer. The correct answer is B. You want to test the model created with training data on a validation data to see how well the model performs with the data it was trained on. So even when whether you use notebooks in the other step, whether you offer using notebooks, you'll still have to do the splitting into training and validation. Right, and that brings us to the end of today's session. Sorry we were not able to see the actual model trained, but if you can follow these steps on your own, you should be able to have similar results. So thank you for joining in today's session. The slides will be shared out to you, and also someone asked for my LinkedIn account. I'm going to share that on the chat in a few. Thank you for joining in.